Let's now talk about a path-breaking piece of Russian technology deployed in an Arctic town in Russia's Far East.
Environment here would not be contaminated in any way and the reactor can continue to operate.
This is happening right now in Russia. Floating nuclear plants, giant icebreakers, fast reactors, and impossible Arctic projects are rising where normal systems fail. In a land ruled by distance, darkness, and cold, Russia is building machines designed not just to survive, but to dominate. The nuclear plant that floats on the Arctic Sea. Imagine sailing through freezing Arctic water and suddenly seeing a nuclear power plant sitting on the sea like a steel island. That sounds unreal, but it already exists. It is called Akademik Lomonosov, and it is the world's only operating floating nuclear power plant. It works in Pevek, in Russia's far eastern Chukotka region. What makes this project important is not just how strange it looks. It supplies electricity and heat to a remote Arctic area where normal infrastructure is very hard to build. In places like this, distance is huge, weather is brutal, and energy cannot be taken for granted. Instead of forcing the region to wait for a traditional power station, Russia brought the power station directly to the region. The plant uses two KLT-40S reactors, and it entered commercial operation in 2020. By January 2025, it had produced its first billion kilowatt hours of electricity. That matters because it proves this is not just an experiment made for headlines. It is already doing real work in one of the hardest places on Earth. And once Russia found a way to bring power into the Arctic, the next problem became just as serious: how to move through it. The icebreakers that turn frozen water into a highway. Power alone is not enough in the Arctic. Even with energy, the region still faces one giant problem: ice. Thick frozen seas can block cargo, delay supplies, and shut down normal shipping routes for long periods. So Russia built machines designed to force a path through that barrier. The Project 22,220 nuclear icebreakers. These are not ordinary ships. They are massive vessels built to crush Arctic ice and keep shipping lanes open for much longer during the year. Russia already has the world's only nuclear icebreaker fleet, and this new class is expanding that system even more. Ships like Arktika, Sibir, Ural, and Yakutia are already part of that effort, while others like Chukotka, Leningrad, and Stalingrad are moving through construction. This matters because the Arctic cannot function on isolated projects. A remote power plant is useful, but without transport, regions can still remain cut off. These icebreakers help connect fuel, cargo, workers, and equipment across frozen waters that would stop normal ships completely. In simple terms, they turn a blocked sea into a working route. And once Russia began solving both power and movement in the Arctic, it became clear this was not just about surviving the cold, it was about building a much bigger system. The reactor built to rewrite the future of nuclear power. Now the story moves away from the Arctic coast and into Seversk, where Russia is building a very different kind of machine. It is called BREST-OD-300, a lead-cooled, fast neutron reactor. From the outside, it may look like just another large nuclear project, but its real purpose is much more ambitious. This reactor is not being presented as a normal power station. It is part of a larger idea called a closed fuel cycle, which aims to make nuclear energy more self-contained and reduce some of the long-term waste problems linked to traditional reactors. In simple words, Russia is not only trying to produce electricity here, it is also testing whether a new model of nuclear power can work in real conditions. The reactor is planned as a 300 megawatt electric demonstration unit, and construction has kept moving forward. In January 2026, reports said the fourth and final shell of the peripheral cavity had been installed, which marked another major step in building the reactor's inner structure. That may sound technical, but it matters because it shows the project is progressing in the real world, not just in theory. What makes BREST important in this story is that it shows another side of Russia's strategy. Some projects are built to survive hard places. Others are built to test what comes next. This reactor belongs to the second group. It is an attempt to shape the future of nuclear energy, not just maintain the present. And once Russia started building a reactor to test a new power model, the next step was even more forward-looking, creating a machine built mainly to test tomorrow itself, the experimental reactor where Russia tests tomorrow. If BREST is a reactor meant to prove a new idea, then MBIR is where Russia is trying to test the future before that future spreads anywhere else. Located in Dimitrovgrad, MBIR is a multi-purpose sodium-cooled fast neutron research reactor. Unlike a normal nuclear station, it is not mainly being built to power homes or cities. Its main job is research. This reactor is designed to test fuels, materials, and reactor technologies under extreme conditions. That makes it one of the most important research projects in Russia's nuclear program. Instead of waiting years to see how new ideas perform in full commercial plants, MBIR is meant to study them in a controlled but highly demanding environment. The project has also moved through real milestones. In August 2024, a pilot batch of fuel elements for MBIR passed acceptance tests. Then, in December 2024, another key installation operation began at the site. These steps matter because they show MBIR is not just a concept on paper. It is slowly becoming a working research platform. What makes MBIR important in the flow of this script is simple. It is where Russia is trying to shorten the distance between invention and application. A floating plant powers remote regions. Icebreakers open frozen routes. BREST tests a new nuclear model. But MBIR goes even deeper. It is a place built to examine what future reactors may become before they are widely used. And after seeing Russia build for power, transport, and long-term research, the story naturally moves to another challenge that defines the country just as much as cold: distance itself. The railway meant to shrink Russia's biggest corridor. Russia is not only trying to solve problems in the Arctic, it is also trying to solve one of the oldest problems inside the country itself: distance. That is where the planned Moscow-St. Petersburg High-Speed Railway comes in. The line is expected to stretch about 679 kilometers and cut travel time from roughly 4 to 5 hours down to about 2 hours 15 minutes. On paper, that may sound like a normal transport project, but in a country as large as Russia, speed changes more than travel plans. It changes how people work, how cities connect, how goods move, and how the map feels in everyday life. A faster line between the two biggest urban centers can make the corridor feel tighter, more active, and more reliable. The project is also huge in financial and engineering terms. Reports in June 2024 said it had been approved with a cost of more than 2.3 trillion rubles. That alone shows the scale of what Russia is trying to build. This is not a minor upgrade to an existing route. It is an effort to create a new kind of movement between the country's most important cities. This matters in the script because it expands the story beyond extreme weather and remote regions. Earlier projects showed Russia trying to survive and operate in hard places. This railway shows something else. Russia also wants to reduce time itself inside its core corridor. It is another version of the same bigger goal, making vast space harder to feel. And if rail can shrink distance between major cities, the next project shows how Russia is trying to overcome distance in one of its hardest regions of all. The bridge Russia wants to build across a world of ice. In Yakutsk, distance is not the only problem. The real barrier is the Lena River, which can isolate the region for long parts of the year. For a city with more than 350,000 people, that is not a small inconvenience. It affects supply routes, daily movement, and access to the wider transport network. In the coldest periods, this is not just a transport issue. It becomes a basic life problem. That is why the Lena Bridge matters so much. The goal is to create year-round road access across one of the harshest environments on Earth. Instead of depending on seasonal crossings, people and cargo would have a more stable connection to the rest of the country. In warmer places, a bridge can save time. Here, it can completely change how a region functions. The project has also moved beyond the idea stage. In October 2025, builders announced completion of the first support, calling it one of the first major milestones. In January 2026, work on the central cofferdam was reported, and in March 2026, Drilling resumed as temperatures improved enough for construction to continue. These updates matter because they show this bridge is becoming real step by step. This section fits best here because it follows the railway naturally. First, Russia tries to shrink distance in its main urban corridor. Then it tries to defeat isolation in one of its coldest populated regions. The railway is about speed between major cities. The bridge is about access in a place where nature can cut people off for months. Together, they show that Russia is not using one single model of infrastructure. It is adapting its projects to very different kinds of distance. The small reactors designed for places the grid can't easily reach. Not every place needs a giant reactor or a huge power station. Some places need something smaller, more flexible, and easier to use in remote conditions. That is where Russia's small nuclear reactor plans come in, especially the systems based on the RITM design. These reactors matter because they are being prepared for regions where normal energy systems are hard to build and maintain. In a country as large as Russia, there are many areas where populations are spread out, weather is severe, and the usual grid does not easily reach. For places like that, a smaller reactor can be more practical than a massive traditional plant. What makes the RITM line especially interesting is that it comes from technology already used in Russia's nuclear icebreakers. That means the design was shaped by harsh environments from the beginning. Reports in March 2025 said 8 RITM reactors were in production, and that the RITM 200N version is planned for a land-based plant in Yakutia, with a target commissioning date of 2028. The design is expected to produce about 55 megawatts of electric power, with a 60-year service life and a 5-year refueling schedule. This section matters because it connects two earlier parts of the story without repeating them. The floating plant showed Russia bringing power into remote regions. The icebreakers showed Russia using strong nuclear systems in extreme Arctic conditions. Now the RITM reactors show how that same hard environment logic is being turned into smaller land-based energy systems. It is not just about one plant or one ship anymore. It is about creating power options for the gaps on the map. And once that pattern becomes clear, the next section can finally bring the whole strategy together. The Arctic build-out that is really about control of distance. By this point, the pattern is hard to miss. The floating nuclear plant, the icebreakers, and the small reactors are not random projects sitting side by side. Together, they form a larger Arctic system built around one basic goal: making remote northern regions easier to power, reach, and operate. The logic is simple. A power plant without transport stays limited. A shipping route without reliable energy stays weak. And a remote region without both remains expensive, slow, and hard to support. That is why these projects matter more as a group than on their own. The floating plant brings electricity and heat. The icebreakers keep frozen routes usable. The smaller reactors promise energy for places where the normal grid fades away. Put together, they start to look like parts of one larger operating system for the Arctic. This is the best place to mention that bigger pattern clearly, because the earlier sections have already built the evidence for it. Saying it here keeps the script tighter and avoids repeating the same idea again and again later. Instead of explaining the full Arctic strategy in several different sections, it is stronger to bring that meaning together here, where the related projects have already been introduced. And that changes the feeling of the whole script. What first looked like a list of strange machines now starts to look like one connected plan shaped by the same hard reality: cold, distance, and isolation. Russia is not just placing technology into the Arctic. It is trying to make the Arctic work more like a usable zone. And once that bigger pattern is clear, the final part of the script can step back and explain the deeper logic behind everything we have seen. The engineering logic behind everything Russia is building. At first, these projects can seem very different from each other. A floating nuclear plant in the Arctic, giant icebreakers cutting through frozen seas, experimental reactors testing future energy systems, a high-speed railway between the country's biggest cities, a bridge meant to connect an isolated region. But when you step back, the logic becomes much clearer. Russia keeps building around the same set of problems: long distance, hard weather, weak connections, and places where normal systems do not work well. That is what gives the script its real shape. The floating plant solves remote energy. The icebreakers solve frozen transport. BREST and MBIR explore future nuclear systems. The railway cuts travel time in the country's main corridor. The Lena Bridge improves access in a region that can be cut off for months. These are different answers, but they are all responding to the same national challenge in different ways. This is the best place to explain that deeper engineering logic, because by now, the viewer has already seen all the evidence. Putting this idea here keeps the script clean. It avoids repeating the same "Russia is fighting distance" and cold message in every earlier section. Instead, the script now pauses, looks at everything together, and gives the audience the meaning behind the machines. And once that idea becomes clear, the ending can finally land in a stronger way. Because this is no longer just a story about separate projects. It is a story about a country trying to design infrastructure for places where survival, movement, and power are always under pressure. Russia is turning extreme places into working zones. By the end of the story, the biggest surprise is not one reactor, one ship, or one railway. It is the pattern they form together. Russia is building systems for a world where infrastructure must keep working in places shaped by ice, distance, delay, and isolation. The projects are different, but they all push against those same limits. That is why the word unbelievable fits this story. Not because these machines feel like fantasy, but because they are being built for environments that most countries would find extremely hard to manage. A floating nuclear plant supplying an Arctic region. Icebreakers opening frozen routes. Small reactors planned for remote territories. A railway designed to compress travel time between major cities. A bridge meant to give year-round access to a region long shaped by seasonal isolation. Together, they show a future built for difficult conditions, not easy ones. This ending works best when it stays simple. It should not repeat every earlier point in full detail. It should just bring the message home. Russia is trying to build a technological future that does not depend on comfort. It is building for the places where ordinary infrastructure starts to fail. Some projects are already operating. Some are still under construction. Some are still proving themselves. But taken together, they show one clear direction. Russia is not just building impressive machines. It is building a future designed for extremes. If this video surprised you, make sure to like, share, and subscribe for more stories about unbelievable projects, hidden technologies, and the future being built right now.